Hello everyone, this is Mr. Isometric and welcome back to the part 2 of our mobile game tutorial series. We are using Unity visual scripting tool for this game, and I think in the last video we just have imported our assets into Unity, and today in this video we are going to check on how to install Unity remote in your Android devices and how to set up the settings for that, because most of the Android users face the problem of Unity remote not working in their Android devices. So I too have faced the problem. I saw so many tutorials online. Finally I got a solution, and I think I should add this into our tutorial series as we move on, because it's a common problem in Unity remote 5. So first thing you have to do is install Unity remote 5 in your Android devices and then plug it via USB cable to your PC. So now let's check on the settings required into your Unity. So first thing you have to do is whatever the version you have installed in your PC or laptop of Unity, just go here and check in the add modules section. In here, for the Android development for making Android games, you have to install all these three packages over here, which is Android build support, Android SDK, NDK and JDK tools. And for the people who want to build for iOS device, you just have to install this iOS build support too. So after installing them, you have to open your Unity project. Okay, so in here, go into the files, build setting, and change your change from PC to Android by just clicking over here switch platform button. And after that, in here, after plugging your phone to your PC, you can see here my Android device is over here, Techno IN6. Okay, so if your device is not over here, you can refresh it, or even if that's not even if your device is not showing till then you can just select all compatible devices over here. After that, go to the edit project settings, and in the project settings in the editor, you have to set your device type to any Android device. Compression, set it to JPEG. PNG will just slow down your gameplay. Okay, resolution let it be normal, and joystick be remote. So we are done in this project settings also, and now let's go to the edit, and this allows me. Okay, so go to the edit and preferences, and in the external tools, if you scroll down, you will see that Android JDK, SDK, NDK, and these two tools are installed over here. Don't even bother to change this black backslashes over here. Okay, they won't be changing themselves, so just leave it up to there, and just check whether if these are checked over here. Okay, and these are all the settings you need to do in your Unity scene. And now for the settings in your Android device, let me just plug my Android phone to my device, my PC. Okay, so as you can see, there is my Unity remote app over here. Okay, so and it says to select a device to use in edit project settings and editor, but ignore this. The first thing you have to do in your Android device is make sure that you are in USB debugging mode. And if you don't know what debugging mode is, just check some tutorials online on how to turn on your debugging mode. Okay, and in here, as you can see, I have selected transfer photos in the USB type 2. Okay, so you might be in the charge this device or use as MIDI, but just check whether if you have selected this transfer photos PTP mode. If you are not in PTP mode, it won't work, so just check that. And after everything is done, you can just open your Unity remote over here, and if I just click on the play button on my game, see my game starts. And okay, so this is my car working over here. Okay, so as you can see, this car will go run on. The resolution is not that good because it is set to the JPEG, and I think it's good enough for testing purposes. This app is not for fully developing. You can also go into the build setting and build your game, but that's fine up to this. Okay, so this is the car control we are going to look. As you can see, it moves with my finger over here. I'm touching the screen, and it's an endless runner car game. So now let's check out this car controller over here. I'll just stop the game, press Ctrl P. Okay, so game is stopped, and this is how the Unity remote works. Okay, so now let's go into our car, and in the car I have flow macro over here. As you can see, this is a car movement flow macro, and this is the node setup I have used. So let me explain how this node setup works. So as you can see, there is a input dot get touch over here, and its index is set to 0. Index value represent the number of touch. So if your device supports the 5 touch, so the first touch will be indexed as 0 and second will be indexed as 1, and similarly for index 5, the index for the touch 5, index will be 4. So as this game is only going to use one finger, I just set this first touch to index 0. And the thing is, if there is not no touch on the screen, and if we try to fetch the data of the touch, it will obviously give us an error. So to stop that, we have to check whether if our screen has a touch or not. So for that, I have used this get touch count method over here. So what this get touch count does, it counts the number of touch presented on the screen. So if my touch count is greater than 0, which is there is a touch on the screen, then this update method will flow into the get touch. Okay, so if you directly attach this to this get touch count over here, we will get an error. So if I just hit play, as you can see, my console is filled with the error known as index out of bounds, and we don't want that error. And as you can see, this node turned to red, so before it didn't. So the thing is, you have to have this node setup for the touch. It's a common setup. Okay, so after that, I have divided this flow into two parts. The first part goes to the set velocity, and we'll get to that, and the second part goes to this branch node. This branch node is if statement, if node in the future 2021 integrated visual scripting tool. Okay, so the thing is, I want to check for the car controller, such as I want the negative value when I move towards the left, and I want positive value so that of velocity, so that I can move towards the right. So to do that, what I'll do is, I'll in the get phase, these nodes you can just find out over here by right clicking on the this panel or the graph anywhere, and just type in get phase, and you will get this touch phase. Okay, these two nodes, every node is available in the search menu over here. Okay, so the first thing is, we want this get phase, and when our touch dot begins, and when it is equal to begin, that means when I start touching my screen for the first time, this node will get triggered, and it will store my current x value position. Okay, so my screen is divided like this, which is this is x and this is y. Okay, width and height, width is x, height is y. Okay, so in here, if you drag and drop it over here, you can just type in position, and you will get this node get position over here. Okay, so get position and get x value over here, because we want to move our car in the x direction. So we will get x, and we will store that into this variable touch position. I have made this variable over here in the scene. As you can see, this is a scene variable which is called as touch position. It is a float type, and its value is set to 0. So just drag and drop it over here, and make it, for making stuff to set, any variable to set, you just drag and drop. As you can see, it is get. Now if I hold down alt button, then it is set to set. Okay, so this is a set variable. If you hold down alt button, okay, so yeah, we have taken our x position, and then we are subtracting it with our current x value. Okay, so this will be playing as we are touching it. Okay, so event is going on. it is fetching the x value, and we are subtracting our current position with the first time, the place where we first touch our screen. Okay, so now this thing gives us a negative value in left and a positive value in the right. Okay, and if you want that stuff in the reverse, you just reverse this to both like this. You just subtract the first position with the current position and you will get the reverse answer, like you will get the positive value in the left and the negative value in the right. And how does this works is, imagine this is your mobile screen. Okay, your mobile screen resolution starts from the bottom down corner over here, bottom left corner. The coordinate of x and y are 0, and at the center they are literally half, and at this top corner over here, where my mouse is, it's the full resolution of your screen. Okay, so to understand this negative and positive concept, I think you can just visualize the, at the center of the screen, assume that the value is 2, suppose. Okay, and if I store that value in somewhere in the variable such as touch position, now the touch position value is 2, right? So now if I move my mouse towards the left, and as the resolution starts from 0 to some number, okay, so obviously there is going to be a smaller number on the left side and a bigger number than 2 on the right side. So if we subtract that smaller number with our current bigger number, then we are obviously going to get a negative number. Okay, and then if we move our mouse towards the right, or say our touch towards the right, the number is obviously going to be a greater number than our current touch position, which was at the center. And if we subtract our current position, which is over here, which suppose it is 3, and our old touch position was 2, so 3 minus 2 is 1, which is positive. Okay, so that's how this stuff works. And also my screen resolution might be, some phones have screen resolution of 1000, some has around 2000, some tablets. Okay, so we don't want that much of value, so for that I have used the clamp f math function. Okay, so what this does is it will clamp the value towards -10 and 10. The values of the screen resolution are obviously high and we don't want that. Okay, so the reason why I am using this clamp math function is because when you touch your screen, even the slightest change in your position of your finger, such as the micro displacements like 0.001, will affect the car and your car will start vibrating in the x direction. Okay, so unless and until our change in position is greater than 10 or less than 10, our car won't move. So for that we are using this clamp function, and I'm taking the clamp function value towards this greater than or equal to or less than or equal to condition over here. Okay, so unless and until my touch from the middle center position, or wherever I am starting my touch from that position, until and unless that position gets above or equal to 10 or -10. Okay, this minus sign just indicates the direction. Okay, so when it gets above the 10, then and only then my car will move. Okay, so when my position is above the 10, this node get activated. This node is called select node, and this is my speed over here. As you can see, if when this condition is false, my speed is set to 0, and when this condition is true, my speed is set to 1 multiplied by 8. So now this normalized node, why did I use this normalized node and not directly use this -10 or 10, is because I want some bit control over my speed. And also if I want to change these clamp values, like suppose I say I want some more tolerance over my touch. Okay, so if I want it to be 20, I can just directly plug 20 over here and change the values over here 20 as well, so it doesn't affect my speed. My speed is still remains the 8, and in the future I'm going to add speed as our game progresses over time. So I'll just make a variable over here and add some amount of speed over it. Okay, so that's speed of our car moving in the x direction as well as our speed of our car moving in the z direction. So yeah, so to get the more control over our speed, I use this normalized node. What normalized node does is it will convert this -10 and 10 to -1 and 1. So any value over here, irrespective of their magnitude, but depending on their sign, this normalized node will convert them into the 1. So suppose if there was minus 50,000 over here, so that minus 50,000 will be converted to unity, which is 1, and that minus sign will be remain the constant, which is -1. Okay, so minus 50,000 will be converted to -1, and plus any number will be converted to +1. So as you can see over here, by just changing that -1 and +1 direction, I can change my car value. Okay, you can also use a lerp over here, but I don't think that that will just make your car go do weird movements, like it will vibrate a little bit. Okay, so I also thought of using lerp, but I think not using lerp is okay. It's still smooth. So now as you can see over here, this value goes into the new vector 3 and directly goes into our set velocity. And you can also use here add force, and then you can also use transform. Okay, transform value over here also, but I'm using set velocity because it's a bit smoother with the colliders and stuff. Okay, it's a rigid body function, that's why. Also as you can see, I have used here a set velocity function again with the help of fixed update, and I'm using this get velocity to just plug over here. As you can see, I cannot just leave this value of y and z to 0, because as you can see, our car is moving in the z direction over here with the speed of 10, or you can say velocity of 10. So here if we have the z value to be 0, then the thing will happen is every frame alternatively unity will have a z value of 0 and 10, 0 and 10, like this. So to avoid that situation, and if we now you'll think, what if we just put 10 over here, then the velocity will be 20 and we don't want that. Okay, so I'll just get the current velocity and plug directly that into here, z to z and y to y. Okay, and in here, we are plugging the x value over here, so we can't plug just this value again over here. So for that I am just using the get x and get y to plug x and y over here. So that's it with the car controller. This is all you need for the touch setup, and the basic touch setup is over here. Okay, so that's it for the car controller tutorial. In the next video we are going to make a endless road. Okay, as you can see, currently my road is spawning by itself. As my car moves a threshold, a new road gets spawned automatically, as you can see in the scene view, and the old road gets deleted. This is for the better efficiency of the game, and we will see these codes in the next video. So thank you so much for watching, and do like and subscribe if you liked it. This is the first time I'm trying this new format, like making the code and showing it directly. I think you all will like to have a broad view of this, so let's just make it big. Here's the zoom, here's the starting of the code, here's the middle part, and here's the last part of our code. Okay, so hope this helped, and we will be making the videos in the future. Could just comment down below what kind of video you want on the visual scripting. I won't be doing any C# videos because I'm not a good programmer. I don't know the C# that much, but these visual codes are pretty easy to figure out. Okay, these are some simple logics over here. I have tried so many combinations for this car, but I think this is the best and more procedural way. So like from procedural I mean we have more control over this. Okay, so yeah, thank you. I'll see you all in the next video.